Remember that the solution to a system of linear equations is the point of intersection where the lines cross. So in theory, you could always solve a system of equations by graphing the lines and observing that intersection point. That is the solution. However, that's not always practical. So I want to give you two algebraic methods for solving systems of equations. The first one is solving by substitution. So we'll follow these steps for solving by substitution. First, we'll isolate one variable in one equation. Whichever variable is easiest to rearrange an equation to get that variable by itself, we'll go with that one. Second, we'll substitute that expression into the remaining equation and solve for the single variable. Third, we'll plug in the solution and solve for the remaining variable. Let's see how those steps work with this example. I want to solve this system of equations, and I have a choice with where to start here. I want to isolate one variable in one equation, so I can choose either of these and either variable to try to isolate. It looks easy to try to isolate the y term right here in the first equation. So I'll start with that. Step one, isolating that variable. I'll rearrange the equation to read y equals negative 2x plus 2. I just subtracted 2x from both sides here. That's step one. I isolated one variable. Step two, let's take this expression for y equals negative 2x plus 2, and let's plug it into the second equation. So I have negative x plus y, but instead of writing y, I'm going to write this substitution for y, negative 2x plus 2, and then that equals 5. So I made the substitution right here in step two. That's the crucial part of solving by substitution. Now I want to solve this equation. So I'll collect like terms. I have negative 3x plus 2 equals 5. We'll subtract 2 from both sides, and I get negative 3x equals 3, and divide by 3, I get x equals negative 1. So we just solved this equation, x equals negative 1, but remember that's only part of the solution. A unique solution has an x value and a y value. So now it's time for step 3. Let's plug in this solution for x equals negative 1, and solve for the remaining variable. I still need to know what is the y value. So step 3, I take x equals negative 1. I can plug it into any equation up here. I'll just choose the first equation, and I get 2 times negative 1 plus y equals 2, which means negative 2 plus y equals 2. Add 2 to both sides, y equals 4. So we've reached a solution. X equals negative 1, y equals 4. You could write that solution either as two different values like this, or as an ordered pair, negative 1, 4, because it represents the point of intersection of these two lines. Let's look at one more example. I'm going to solve the system of equations by substitution, so I need to choose one variable in one equation to isolate. It looks like it will be the easiest to isolate this y in the first equation. So that's step 1, isolate one variable. I'll subtract 3x from both sides, and I get negative y equals negative 3x plus 10. I'll divide everything by negative 1 to undo that negative sign, and I get y equals positive 3x minus 10. Okay, so y equals 3x minus 10. That's our substitution for y. That's step 1. Step 2, we'll take that expression, y equals 3x minus 10, and we'll plug it into the second equation. So I have 6x minus 2y equals 5, but instead of writing y, I'm going to write this expression or substitution for y, and it's equal to 5. Then we solve this equation for the single variable, which is now x. 6x minus, let's distribute this term, so minus 6x plus 20 equals 5. Something strange is going on here. I have 6x minus 6x, so that's 0. This equation simplifies to 20 on the left side and 5 on the right side. That's a contradiction. That's not true. There are no variables left to solve for. Notice that the variables canceled out here, and I'm left with this contradiction, 20 equals 5. That's an indication that this system of equations does not have a solution. If I were looking at the graph of these lines, those lines would be parallel lines. They would never intersect. So there is no solution to the system of equations. Anytime you see a contradiction like this, you can conclude no solutions.